stream?
Give me about 20 seconds.
Okay. Tom is
Okay.
here. All right. Great. Good morning, everybody. Welcome. This is the Thursday, October 22nd meeting of the School Building Project Sustainability Subcommittee. I am going to call the meeting to order and do a quick roll call. Ken Aries.
Here.
Brian Baer.
Here.
John Cummings.
Here.
Nancy Hyde.
Here.
And I am here. Julie Gervais.
Here.
And Tom Philbin. I don't see Tom. Do we know if Tom's joining us today?
Yeah, I believe he is.
Okay. Okay.
I'll
Why don't
text
we, yeah, if you can text him. I want to get started because we have sort of a lot to cover.
Yep.
So before we start, I'd like to recognize the live stream available at www.westwood.k12.ma.us//live. I never know which one's which. To provide real-time public access to the activities of the School Building Sustainability Subcommittee in accordance with the March 12th, 2020 Executive Order of Governor Baker. So today we have a couple things on the discussion items agenda. The first thing is the net zero energy discussion. I would like Tom here for that. So you know what, I'm going to take these out of order. What I'd like to do is, why don't we just start with the HVAC system.
I just emailed Tom just to tell him.
Okay. All right, great. So I know that we had some back and forth on the HVAC system. I know John and Ken, John Cummings and Ken, you guys had a couple questions about the HVAC system that I think have been answered in the interim. So can someone provide a summary of where we are? Chin, I don't know if you want to do that. I'm happy to do it. I'm just, you know, thinking about who's best placed to do it.
Rob might have the better, that has
Sure.
the most complete info.
Sure.
Okay.
So we met last week with John Cummings and Ken Aries and our engineers. And we went through kind of a little bit back and forth on pluses and minuses of going with the MERV 14 versus the MERV 16 filters versus adding the ultraviolet light into the ductwork. And the result of that was that GGD was planning to come to today's meeting with a diagram, which I can put onto the screen, and I can kind of let Dom kind of go over that. But essentially, the discussion was, you know, what are the energy use ramifications of going to using a MERV 16 filter, which is a higher level filter. The MERV 14 filter is what is recommended by the CDC and ASHRAE for new construction. That's what we currently have in our design. The MERV 16 goes a little step further than that. And so it allows less particles to pass through, but it also requires more energy and higher volumes of air. And then there was some discussion of, you know, do we use the ultraviolet light in lieu of, you know, the MERV 16, or which direction do we go? So that was part of the discussion, and we were going to carry that forward to discussion today. The other thing we talked about was the design degree day, and, you know, the town of Westwood has, according to the guidelines for the weather station, it's 3 degrees in the wintertime is the design degree day. Less than 1% of the days are at that temperature. And based on that temperature, the system is designed to satisfy the 70 degrees interior temperature for that. If we use 0 degrees, it would require us to bump up the size of the overall system and an additional additional well, like 4 or 5 additional wells. And it seemed to me after some discussion, and people can chime in if I'm wrong, but my understanding was people felt comfortable with staying with a 3-degree design degree day. That seemed to satisfy, you know, the temperature swings. And then the other aspect of that is that, you know, our building is super insulated with, you know, R24 walls, R60 continuous insulation in the roof, R10 underneath the slab, plus the passive house, you know, air infiltration standards. We felt that it would take longer for the temperature to decrease inside the building. So all those kind of factors played into the decision. My understanding from the group was to stick with the 3 degrees as the design degree day. And then finally, the last item was the natural gas generator versus a diesel emergency generator. And there was some discussion back and forth on that. The consensus from the group was a recommendation to go with the natural gas generator. It's something that the school district already uses at the high school. There is, our engineer confirmed with the utility company that it is possible to extend that from Laura Lane to the building, so it's a short distance to add it. There is an additional cost associated above and beyond the diesel cost, which we had been carrying previously, which is roughly in the range of $100,000 to $150,000 additional. But the natural gas generator is easier to maintain, and the school district is very comfortable with that, and our engineers agreed that it was a good decision or recommendation, and so I believe that's the direction that is being recommended. John or Ken or anybody else that was in that meeting, let me know if I missed anything.
All right.
Okay.
So it sounds like just to kind of recap, it sounds like the only sort of issue that is really open. So the design degree day is not changing. It's staying the same. All those questions were answered. We're at 3 degrees. And the emergency generator, we're going to go with the natural gas. I believe there's the generator itself costs a little bit more. There might be some additional costs to bring the gas line to the property. Is that correct? But overall, I think it just everyone seems to agree it's a better system for the school. So it sounds like the natural gas generator is what we're going to put in place. Is that right?
Yeah, and so we want to bring that forward to this sustainability subcommittee, make sure everyone else is on board with these recommendations.
Okay.
Discussed.
All right. So putting the MER 14 versus 16 aside, because I think that's open issue. What is everyone okay with the 3 degree design degree day?
I think it makes good sense. And practically speaking, I don't know if the buses run on those low temperature days. So
days, right.
I do recall a snow day in the past, I want to say the past decade, when it was just so cold that school wasn't held. So from a practical standpoint, I just want to add that I think it makes sense, but the analysis sounds thorough and I support it.
Great. Does anyone disagree with the 3 degree design degree day?
No, but we did, the engineer is going to add in stubs to the line, right, Rob?
Okay.
So if we should get caught in a really cold snap, we'll be able to do something immediately with the system.
Right. The discussion, and correct me if I'm wrong, but the discussion was to add valves onto the system so that in the future, if there was a desire to add like electrical supplemental boiler, they could add that and it would, without having to increase the size of the electrical service coming to the building. Dom, I don't know if you have any follow-up to that.
Nope, that's correct. That's an accurate statement of the discussion. So we're going to be planning a valved and cap connection for a side stream supplemental electric boiler, which either a rental boiler could connect to, or down the line, If one was purchased, it could be installed. So the other thing too is with our space planning for the mechanical room, we're also going to count for the room, for a future potential boiler. But just valve and cap connections been designed now.
And this is different than, the option that we had reviewed, the tier 3 option that we had reviewed before, because in that scenario, the electrical supplemental boiler was integrated as part of the design to reduce the number of wells. Whereas in this scenario, we're designing for the full geothermal wells. And this is strictly, in an emergency situation, if there was, some sort of drastic event that happened.
Okay. Great. So it looks like we're all set with a 3-degree day. And then the natural gas generator, does anybody have any opposition to that and prefer diesel, or any questions about it?
We did talk about the soundproofing and the decibel at 21 feet and chin.
I think the simple answer to that issue is that the design team will design to meet the state noise criteria standard, no matter what system, what kind of generator. So there should be no differences in that, and Dwayne Whittier will take care of that.
Okay, great.
Is there any comment, just for the record, on the fuel efficiency of natural gas versus diesel and how it relates to, this sustainability issue?
Dom, I don't know if you have any comments on that, but this is strictly an emergency use generator, so it's just if there was an extreme weather event, or something along those lines, and so the amount of fuel that would be used is minimal, and the natural gas is there, ready. Where as the diesel, you're buying a big tank of diesel fuel that's sitting in a tank, and over time, if it's not used up, it can create problems. And so, you would have to kind of use that up. Whereas with the natural gas, it's really just on an as-needed basis whenever you're doing the testing each week. So they're both fossil fuels, either way you look at it.
It's a lot easier on cans for Ken or in terms of the maintenance in the future, because the diesel, if it is sitting in the tank after a certain time, it actually need to be pumped out and replaced. And then so what you will add is that a lot more handling, and then a lot higher. You will increase the chance of spillage and so on and so forth. And having the natural gas, that you don't have the leakage or spillage that you have to think about going into the future. And then the handle that you don't have the labor of moving the old diesel fuel out of the tank and going into somewhere else.
The only other thing I could add is, in general, natural gas is considered more, a cleaner burning fuel than fuel oil. Fuel oil has, more energy per equivalent, measurement. But in general, because it's cleaner burning, the natural gas will produce less carbon dioxide output.
Sounds good. Thanks.
All right. Any other questions? Natural gas generator? Any other comments? Nope. Okay. So I think that that will be a recommendation that we can vote on to move forward to the SBC. We'll do the votes at the end. I think it's just easier. So the final discussion on the HVAC system, and I know the Sustainability Subcommittee has become almost an MEP, a Mechanical Engineering and Plumbing Committee. So thank you for indulging us on this, but I think we have the right people on this call to make these recommendations. So I appreciate the indulgence. Last one is the filter issue, whether it's a MERV 14 versus MERV 16. I believe it was spec'd as a MERV 14. The CDC, I think, is recommending MERV 14. There was a question from our team about whether MERV 16 would be better. And now I'm going to turn it over to someone who knows more than me, which I assume is either Rob or Dom.
So I just put up on the screen, this was the diagram that was discussed, that was requested for us to prepare. Dom or Matt, if one of you want to kind of walk people through this and explain what it is that we're looking at.
Yeah, Matt, why don't you lead the discussion on this diagram, please?
Sure. So this is a typical airflow diagram associated with the roof-mounted air handling units that will be provided for the school. This diagram is I removed a bunch of sensors and components so that we could see the main, the fans, the coils, the energy recovery wheel, and most importantly the MERV 8 and more MERV 14 filters. Also the germicidal ultraviolet light assembly. So this diagram is mostly to help everybody viewing get a good understanding of the airflow direction and where these components would be placed within the units. Up top, yeah, so bottom left, that works. That's where your outside air enters the unit. It hits a MERV 8 pre-filter, and under normal operation, it would go through the energy recovery wheel. So the filter just protects the wheel from outdoor contaminants. The air then travels and mixes with return air. Yep, just like that. And then that mixed air will go through the MERV 8 pre-filter and MERV 14 final filter before entering the chill water coil to be subcooled. So the recommended placement of the germicidal ultraviolet light assembly would be just after the chill water coil, because the drain pan beneath the water coil and the moisture that wicks off of the chill water coil is susceptible to growth, microbial growth, and the ultraviolet light assembly would help or would kill the growths, as well as anything that's coming back in the return airstream, which was the main concern of the group last week. Sick kids, you get that return air coming in and mixing with the fresh air, and we wanna neutralize cold, flu, virus, all of that. That's where we would recommend placing the ultraviolet light assembly. So from there, we hit the hot water coil, and the supply air fan delivers the mixed air out to the space for ventilation, cooling, and dehumidification. Next slide, please. So here is the actual basis of design units for the Hanlon School. This is a manufacturer's diagram. It's a little tough to read, but I tried to fit it on here large enough to see. I'll just quickly run through this. The top plan view is the most helpful in this discussion. And you see there's little A, B, C, all the little numbers indicating different sections of the unit. On the right, we have a table that indicates what these sections are, so everybody can understand what we're looking at here. So let's see, A, B, C, plenum sections, A, B, C. So B, top left corner, that is where the exhaust air exits the unit. And then just beside C, below, is where the outdoor air comes into the unit. So then if we go down the list on the right, panel filters D, you can see that section there. So that's the MERV 8 pre-filter that you have access to pull it out right from door D there. Let's see, we have F is where the energy recovery wheel is. You need access to that for cleaning, possible replacement. So that is via door F. Let's see, G, H, I. Okay, we have another at K. K, we have another panel filter. That would be the return. That's the return air MERV 8 filter. So it filters before it hits the wheel again or recircs. Let's see. Return fan is N. So that's the return fan there. You have access to those components there, and it looks like the other fan would be the supply fan with access via door R. Let's see, where is, looks like O. O is just before the cooling coil. That is the MERV 14 or MERV 16 filter that we are discussing currently. So this correlates with the diagram we were just viewing. I think that's all we need to discuss here.
Well, that actually, let's go back. The just P while we're there. Great job, Matt. At P is a cooling coil. So right around there is where the UVC would be added,
right,
if we're going to add it.
Where's the crossover?
It's at H, between the G and H. That block in between the two.
Here.
So if we're recircing, the air would travel back and not go over the energy recovery wheel, but go 90 degrees through that tunnel.
Can I ask, so I'm just curious, and I apologize if I'm getting, others know this. Is the MERV 8 and the MERV 14, or whatever that other higher MERV, that's going to be installed whether, I mean, this has nothing to do with the pandemic. This is just about indoor air quality, right, in general?
Correct.
Yes, but the MERV 16 does have a higher efficiency for capturing smaller particles, which
I guess what I meant is this in reaction to the pandemic, or would we be doing this if we didn't have that pandemic?
I think we would be at MERV 14.
Okay.
Regardless, the discussion really is the MERV 16, the upgrade.
Okay.
So just to kind of summarize our options here, right? I'm just conscious of time. So our options here is we do MERV 14 on supply, MERV 16 on recirculation, right? Versus that's one option, right?
It would be I'm sorry. It would be either a MERV 14 or a MERV 16 right at O. And the reason for that is we would have to have MERV 13 or let's say MERV 14 there anyway. So it would be a matter of upgrading that to MERV 16 rather than just adding and say at K, if we did a MERV 16 there would be a very big pressure increase because we would still have to have it at O. So that was discussed a little bit last week. So it would just be an upgrade from 14 to 16.
Okay.
And associated with that, that upgrade to 16, you had talked about a semi-custom rooftop unit. Is that what would be the case here if they did decide to go to MERV 16?
I think we were able to work with the manufacturer on this. We don't have to go quite to the fully custom line. It is a Dakin unit, which is good. So that's kind of since we last talked. I don't think it's a full change to a custom unit. We're able to.
I just want to make it sort of in a very simple way to think about it is that basis of design where we start is a MERV 14 standard unit. Pretty much that's something that they've been doing for a number of years. If we go to MERV 16, the unit would have to have larger motors in order to push the air through the filter because it's a much finer filter. And that there are fewer manufacturers, and then we may or may not get into semi-custom, but definitely will be a better unit because you're buying a higher end unit in order to be able to push the air through, and that there's a cost on the capital cost, and then there's a additional energy costs because you are operating with a bigger motor, pushing more, pushing in order to push the air through. So those are the main difference between the 14 and 16 in terms of the impact to the project. And 16 obviously gets you better air at the when you deliver into the building.
Chin, what does that cost?
Dom should be able to, that's what we asked GGD to provide that information.
Yeah, it's similar to our best estimate is similar to what we talked about last week. It's probably on the order of
225,000 is what we have.
200, probably 200,000. And based upon our conversations with the manufacturer, the overall impact we reviewed the cost that was carried in schematic design is probably less than that, the impact. Because like I said, these aren't fully custom units. The main change is to go from a 4-inch depth filter to a 12-inch depth filter. So that added metal to it, it's probably less than the 200,000.
Okay, I think I'm Chin and Tim, I think we're getting a little bogged down in the details here. I know we've had multiple discussions about this issue, and I think what this group needs is a short summary of pros and cons for each option, whether it's MER 14 with and 16 or MER 14 with UV or MER 14 and 16 and UV, and accompanying costs. And I know that, people we need to get into people want to get into the system, but I think we've spent a lot of time on this HVAC system issue, and I know it's important, but I really need to streamline it a little bit. We have a big discussion about net zero energy that we need to get to. So how do you suggest, Rob or Chin, how can we streamline this discussion?
Maya, can I for a second?
Yep.
So if you go back to the diagram too, just so everybody's looking at the same thing. With the suggestion, my suggestion was that we put 16s in the crossover between the recirc line. That is, we can't do that. To put 16s where the 14s are now is you have to go with a more expensive unit. So last week we just were rehashing everything, but we all agreed that if we left the 14s and did the UV lights, that would give the higher level of protection that we're looking for.
Okay.
How's that?
I like that, John.
Recommendation then.
Hey guys,
So
I
that's
have
the
to jump off for a few minutes. I'm just going to mute video and sound, and I'll be back. I got to take care
Okay,
of.
thanks, Ken.
Thanks. Bye.
Okay, so that after your discussions, that's what you've come up with, right? Stick with the MER 4 and add a UV.
MER
14.
Sorry, MER 14
and add the UV.
and add a UV. And what's the approximate cost of the UV? Because that would be the additional cost, right?
Last time when we talked about it, the cost is somewhere in the 80,000.
Okay, and that gets us to about 90% effective, is that right?
Yeah.
It's 90% of whatever comes through MER 14.
Right.
So you're getting a double effect, which is, so if you take 0.1 times 0.1, that become much better in terms of the end result.
Okay.
The downside of, I was going to say, the only downsides, some of the downsides of the UV is, increased cost, increased maintenance, and I think that it was Lemma that had raised some other concerns with it last time.
The UV light has on that particular option is that the UV light we could do it as a alternate in terms of that if there's the budget allows that we go for it, and because we can buy a unit that without the UV light UV unit and then just at a later date put it in or not. So that's another way to look at it, and it does consume energy.
Right. If we do it as an alternate, that means we need to be okay with MER 14s.
Correct.
So John, are you okay with MER 14s? I think we've lost John.
And it is a maintenance item, and then those and it's a light
Right.
that you have to.
Yeah.
There's a light bulb. There are light bulbs that you have to replace.
Right. Okay. So, John, are you there? John Cummings?
Yes, sorry, I was just
Okay.
on my coffee cup.
Are you okay with, if we do the UV as an alternate, it means we need to be prepared to cut it if we have to. That means you need to be okay with the MERV 14s and not the upgrade to the 16s. Just, I mean, hopefully we'll get it in, but if, looking at it as an alternate means that there's a possibility that we would not put it in. Are you okay with that?
I think you need to have the 14 and the UVs. I don't think you can cut it out.
But why
Okay.
wouldn't we just get it priced, May, and then make that decision? Because I mean,
I thought we had a price, right, of 80?
well, we have a budget, but I mean, we're gonna get it as part of the SDS.
Okay, so why don't we move
Okay.
forward with it as an alternate, knowing that we probably want to keep it? And that would be the recommendation of this group. Does anybody have any other questions on it? So again, we're going to do MERV 14s, not upgrading to MERV 16 filters, but including a UV system as well to increase the effectiveness of the filtration.
Yes.
Maya, why would it be on the alternate list?
I think just purely for cost reasons. I think because you can structure it as an alternate, is what Chin is saying.
It's one,
So
okay.
you can add it. It's not something that has to be included in the system. You can sort of add it or delete it. So
Got
I
it.
think that's the only
Got it.
reason to add it as an alternate.
It's one of those items that you have that flexibility.
Exactly.
Thank you.
And you can put it in afterwards if you have to.
Right.
That's correct.
Great. All right. Does anyone have any objection to this recommendation, moving this recommendation to the SBC? No? Last chance. Okay. We'll take a motion at the end. So just moving on now to net zero energy. I just wanted to set this up a little bit for us. What we wanted to really understand is what this group thinks about net zero energy, and how important it is to the project to achieve net zero energy. I think that Rob, if you can give us a little bit, or Eric, I don't know if you'd want to do it, just give us a little bit, sort of a quick primer on net zero energy and how we can achieve it in our circumstance.
Sure. Well, I think, to step back for a moment right now, or to start, right? The straightforward definition of a net zero building is that the building produces as much energy as it consumes, right? And so that would require a on-site solar or some sort of renewable energy technology that produces as much as the project consumes, right? Currently, having that renewable energy on the project is not part of the project, right? And so what the team is working towards, which is, we think, the right approach, is designing a low energy building that is all electric, that will then be able to offset any on-site energy use through off-site sources, right? And so that is admirable right now, and is the direction we're seeing a lot of schools going, and it allows for the future installation of any sort of renewable technology. And then at that point, you could be considered net zero through on-site generation. But if the town was interested in claiming to be net zero from day one, assuming no on-site renewables, then the option there is to purchase renewable energy certificates from off-site sources, right? And so we had a little bit of back and forth. Well, let me stop right there. Are there questions on that basic level of definition? And you can see there's a lot of there's a lot of different ways people talk about this interchangeably about, on and off site generation. There are different tiers if you get formally into it, but, I want to continue to commend the project team for pushing towards a low energy building that's all electric, that is set up to be net zero on site in the future, should that be
Yeah.
available.
What we should point out here is that regardless, anything that you do with a power purchase agreement, which is 100% of everything that's done in the state of Massachusetts, you cannot own the RECs. The RECs become the property of Eversource.
Yes, they do now.
They're not the property. They're not the property of Amoresco.
Yep.
They're the property of Eversource.
Right.
And then Eversource just gives the incentives then, because you have it on your site, gives the money essentially to, some of it goes to Amoresco, and this amount will go to the schools. So what we lose by not having the solar, if we could have it elsewhere, is the actual money that comes out of the project itself that goes to offset electric bills. So by moving it wherever we move it, if we find a place, we will give up that amount of money, and we will also probably get less incentives per kilowatt hour, because we'll lose our place in the SMART program. We'll be at a different tranche, and assuming I can't predict the elections, I wouldn't want to even try. Depending on who gets elected, the investment tax credit may be gone before we get far enough along with the school to do it. So I would say that essentially, given what we're doing now and not having the solar on the site, we should be sure that we design the building so that it's solar ready.
Mm-hmm.
It is.
And that is part of the design right now.
Right, and that involves all this equipment that's on the roof, placement so that we don't have shadowing, and again, minimizing it. And I forget whether it's north, south, east, west, but how you orient the equipment itself on the roof is very important.
Right, and that's been a consideration of the design team throughout. There was some, they're looking at placements and penetrations, and really just the orientation of the building. If you recall back, seemingly a zillion years ago, at one of our earlier meetings, where there were shading studies done to evaluate solar availability and maximize solar availability from different layouts. So all of that is part of the current project to make it solar ready and maximize the solar potential on the building itself.
Yeah, I mean, as I pointed out, we had myself, Rob, and Eric were discussing this last week, and the DOER essentially commended us for the goal we have with EUI, the 21 they feel was superb. And the only thing they're saying is that by getting renewable credits from outside of New England, we give up the adder that goes on the alternative energy credits. Yeah, because of the geothermal system. Yeah. We are entitled to incentives. Those incentives get increased by 40% if you buy your RECs from New England, which probably we don't want to.
Yeah, so that's a different discussion, but an important one too, is because the project is scheduled to use a ground source heat pump system, where there's the thing called RECs, right, for solar power generation. There are these alternative energy certificates that are available right now through a CEC program, a Massachusetts program for ground source heat pump systems. So this is another financial tool or benefit for the project for using that system. And basically, you have to quantify the amount of heat generated via that system, and you you get these alternative energy certificates that you can sell in an open marketplace, and then you get money for using those systems. So it's similar to the incentive for what's making PPAs work and what's getting increasing the solar development in Massachusetts. This is just rewarding other technologies. So there's a whole bunch of math that goes into this, different adders for different system sizes. And one of the adders, what Tom was alluding to, is a...
So Eric, to bring back the discussion to to this is, I think that, yes, those are things that we can go after, and then we will have to go after, and then for the time being, I think that what we have as design is an ultra low energy, fossil fuel free, solar ready, net zero ready building. And then I think that's something that the committee can just simply go out there and claim that, and because we are solar ready, and then we can do the PPA and purchase the certificate all independent. I would recommend the committee to just simply accept this description for the time being until a decision is made to, if we want to go for net zero, because that decision can be made whenever.
So there's really nothing for us to do at the moment. I mean, I know, Tom, that you mentioned solar panel ready roof, which we have, but I would think that installing solar panels on this roof would be part of a larger Westwood plan, right? It would be sort of in the context of what the rest of the town energy plan is. But it looks like the school is ready to accept them if that's something that we want to do, if Westwood wants to do a PPA and put solar panels on the roof. And in terms of the school itself, as Chin said, it'll be ultra low energy, all electric, net zero ready. And that's, I think, really where we are, right? And until we sort of understand what the town energy management program is and what the town is doing, that's sort of where we are. Is that right?
That's correct. And the whole thing, of course, is making sure that the building is designed to take any solar that we may choose or not choose in the future to put on the building, because nobody can predict at this point where we're going to be two or 3 years down the road. Where there's going to be a big push toward solar, but whether or not it's going to be economic to do it and when it's going to be economic to do it, just be ready to do it is the point. And as long as we're ready, I think that's really what we ought to design for right now.
All right, and it sounds like we are ready.
Right, and we can't predict the future, but what we've seen in the past is that the cost of renewable energy has significantly decreased. We were talking $10 a watt installed 8 years ago, and now we're at the $2 range. So the price of solar energy has significantly declined. There's still the potential for the power purchase agreement, and even in that situation, when the RECs are stay within the SMART program, the overall benefit, what you're driving towards is you're promoting the use of renewable technology. And this gives you a little flow chart of how the RECs are deconnected from the renewable energy generation, and then go into a separate funding source.
Eric,
yeah,
that's not the focus of that's not, I mean, we will be dealing with this, but for the time being, we need to move the project forward.
No, I hear you. So just go to the next those next slide for just, this was a question before, otherwise. No, sorry. So the question was, one more slide. If we were to buy RECs based to offset the assumed use right now on the open marketplace, these aren't Massachusetts RECs. And this number actually is a little low, but it would be, based on updated numbers, around $1,000 a year to buy RECs to offset the building use. And then you not only have this low energy building, but you can claim net zero.
Okay.
It
So-
could, but it's really, at that point, it's cosmetic.
It is
And
cosmetic.
we don't really get anything for that 1,000. I mean,
No, you don't, other than to be able to say that, right? And
Yeah.
it's promoting the, off renewables elsewhere. You go into a Whole Foods and it says this store is powered by wind. It's
yeah,
not
but the
actually
argument
what
back to you is
they
you're
buy.
helping Texas. You're not really helping Massachusetts, and that's
Correct. Yep.
that's what DOER will be coming back at you. If you
Yep.
buy the New England ones, you're probably talking to 5-10 times as much money, and you don't want to spend that much.
I think the point is, right, the bigger picture is that, number one, like Eric said, this is a very low energy use building, right? We've designed this to reduce the amount of energy consumption to the lowest extent that we can. And that leverages us in a good position to be able to supplement that with renewable energy, right? And so whether that renewable energy comes from other places around the country, from New England, Massachusetts, it's still renewable energy and it's not fossil fuels. That's number one. The second piece is that, this is designed to support PV. So if at some point the school district decides they want to put PV on the roof, then they can. And that PV can be supplemented with additional RECs. And so you could have a mix of PV on site and supporting renewable energy elsewhere. So that's really the bottom line, and that we're designing an outstanding building here, very low energy, good for the environment, good for everybody.
And because it's an all-electric building, right, as the grid continues to clean up, right, the grid is becoming cleaner. Your building, in turn, becomes cleaner because it's just using the electricity, right? And it's got no on-site combustion of fossil fuels. So this is the approach that is that we recommend. That is the right approach to move forward to build a sustainable long-term school.
I mean, if you look at it from a town-wide perspective or a school system perspective, one of the things that we should think about is if we build enough solar and generate enough incentives elsewhere, however we do it, and we take and pool those incentives, eventually, if this school is designed to be solar ready, we may be at the position where using those incentives, we actually pay for the system that we would put on the roof, own it outright, and use it to essentially reverse the meter and have it actually partially power the school itself. So that would be the ideal, and that's something that making this building solar ready and making it as low energy as it is would greatly facilitate if we had the opportunity in the future.
Great.
So the
So the
last item was the lead checklist, right? If we can just run through that quickly, Eric.
Yeah, sure. So lead checklist, if we recall, right, MSBA requires that we hit a minimum level of LEED certified here, which is satisfying all the prerequisites and hitting 40 points. We're currently comfortably above that 40-point threshold, very much within shooting distance to hit silver. We as a team are working to refine this as the design progresses. We see no issue with meeting that minimum requirement. The additional incentive is around the energy performance of the building. We have to show at least that 14 points in the optimized energy performance credit. And right now we're on track to exceed that requirement as well. Beyond just low energy building, we're holistically designing a sustainable school, and we'll continue to evaluate options as the design progresses to target the appropriate sustainable strategies in the project to hit the highest LEED certification level that's within the project's tolerance.
And just to follow up on that, sometimes when people think of LEED, they think, oh, it's just energy efficiency, or what this is showing is that there are many categories. There are multiple facets of the project that are good for the environment. From providing pedestrian-friendly, passages to the building, reducing the amount of impact on the site, low water use, very efficient, fixtures that we're using in the building, to the energy management systems and low and high efficiency mechanical systems, to the amount of insulation, to the types of materials that are either from recycled products or can be recycled at the end of its life, to the indoor air quality levels of thermal comfort, daylighting, and then and so all of those come into play. So what it's showing is that we're taking a holistic approach,
Right.
designing a green building.
Yeah, and the two items that give you the biggest bang for the points, rather, is the energy and is the air quality. And in both cases, I think we're going at the as good as could be expected.
Great.
And are really most important, right? Especially in a school
Yeah.
environment, you want to build a school that's healthy.
Rob and Eric, I think that what would be helpful is that if we prepare a slide when we go to the community meeting so that we can have a few talking points that we can explain to the community how great this building is.
Okay.
Yeah, I think that would be
Can
helpful.
I ask
Sort of
for
that.
something else too? When we talk about the energy and atmosphere section, and specifically that line that was referred to, the optimized energy performance, it'd be nice to know what's behind those 16 points and how we get to 14. And as you noted, that we are moving towards the 16.
Mm-hmm.
It'd be nice to know the components of the building that are accomplishing that outcome.
So what that is that's GGD is doing a whole building energy simulation, right? The energy model, right? Mm-hmm. And so that compares the building against a baseline and how much better do we perform. So it's a holistic look at all of the energy components within the building. And so they've issued some preliminary models, and we'll continue to use that energy model as a design tool to make smart choices as we move forward. But we can flesh that out a little bit more and for this talking point slide.
Is the enhanced commissioning that's under the energy, is that just energy? Because enhanced commissioning is something over the whole project in general.
The Lee has a specific language of what they are looking for, but this project probably will go beyond that anyway, because we're also looking at a better building envelope, infiltration rate, etc. So, and these are, MSBA has its own requirement, which is part of the project anyway, but we will be working on that in the more specifically as we move forward in building the project budget.
Right. So the MSBA supports that commissioning activity, and it's in line with the LEED requirements there.
Yeah. But what I'm saying, in essence, is that what we don't want is what happened in the high school and the library. We need somebody that's going to be all along the way, watching every step, so that we don't end up at the end of the project or somebody, a contractor going bankrupt and then having to go, the nonsense that killed the library project and killed the high school. Maybe 5 years after it was finished, we were still fixing it. We don't want anything like any close to that.
I can't speak to it.
Will help that.
Yeah, I can't speak to what happened there, but for what the MSBA does, they're going to engage a commissioning agent in DD. That'll be part of that will actually answer directly to the MSBA. They're a third party. They do design reviews of the DD set.
But for the enhanced commissioning, we have to pay extra, which we'll put in the budget, Chin, for the 30.
Yes, understood. Yes, that's already in the working.
So it's a totally different regimen now, Tom, versus the high school and the library. I mean, it's a much more intensive quality control particularly around commissioning.
Yeah, and the MSBA requirements has some language on monitoring for the first year of operation. There is a warranty period callback where they come in, make sure everything's operating before the end of the warranty period of equipment. So there is that post hoc scope that's included, and includes some training as well for building operators.
Great.
Um,
Thank
so
you.
it
Look,
sh-
I'm conscious of time. It's 10:26. I'd love to wrap up by 10:30. Does anyone have anything else on the lead checklist? Nope. Okay. So it sounds like we're on track for, which is great to be certified, and maybe even silver, which is fabulous. So thank you very much to Doran Whittier and to the Green Engineer for all of your hard work in getting us where we are. I think this has been a great discussion today. I'm going to move on to the action items. So the first thing that's not on here actually is I'm going to ask for motions to approve the recommendations for the HVAC options. So the first one is I need a motion to recommend to the SBC that we use 3 degree as the design degree day.
Motion to move forward with the 3 degree day.
Can I get a second?
Second.
Great. I'm going to do roll call. Ken,
Yes.
Brian,
Yes.
John,
Yes.
Nancy,
Yes.
and I am a yes. So that motion is carried. Can I get a motion to recommend to the SBC a gas generator as opposed to diesel for the emergency generator, a natural gas generator?
So moved.
Second.
All right, roll call. Ken,
Yes.
Brian,
Yes.
John,
Yes.
Nancy,
Yes.
and I am a yes. So the motion is carried. Final recommendation is to install MERV 14 filters and put in UV system as an alternate. Can I get a motion for that recommendation to the SBC?
So
So
moved.
moved.
Second.
All right, Ken,
Yes.
Brian,
Yes.
John,
Yes.
Nancy,
Yes.
and I am a yes as well. Motion is carried. Next motion is to approve the subcommittee meeting minutes of October 8th, 2020.
I just
Can I
said
get a
one point for that.
Yep.
If John could add, so he quoted me as saying that I stated that I'd definitely like to increase the system to a MERV 16 for the recirculated air. Because that's you don't really, it's not so much the air coming in or out of the system, it's the air that's been in the school going back into the school.
Right. So not the supply, but the recirculated, correct?
Right. And then
Okay.
if that's the case, I'd like to move that we accept the minutes with that one addendum.
Okay.
Second.
All right. Any discussion? Nope. Okay. Ken,
Yes.
Brian,
Yes.
John,
Yes.
Nancy,
Yes.
and I am a yes. Okay. Motion is carried. Is there any new business? I know I was cutting some of these discussions a little bit short, but I think we definitely, they ran their course enough, I think. So does anyone have any new business? Nope. Okay. Can I get a motion to adjourn?
Motion to adjourn.
Anybody?
Motion to adjourn.
Thank you, Ken.
Look at that motion.
All right. Roll call. Ken,
Yes.
Brian,
Yes.
John,
Yes.
Nancy,
I think so. Yes.
and I am a yes as well. Motion has carried and we are adjourned right at 10:30.
Oh, you're good.
Thanks, everyone.
Thank you, everyone. Appreciate your time.
I know.
Thanks.
Thank you, everyone.